Good day, everyone. This is Arvin Enriquez, your subject teacher for probability and statistics. With this video lesson, we're going to discuss the process of computing the mean of a discrete probability distribution. Our lesson objectives: at the end of this lesson, you are expected to illustrate and calculate the mean of a discrete random variable, interpret the mean of a discrete random variable, and solve problems involving mean of probability distribution. Before moving forward to our discussion with this video lesson, let's recall what is a probability distribution table. So before we consider that your table is a probability distribution table, so you need to check if the total or sum of those probabilities under the table is equal to 1. So if not equal to 1, then we cannot consider that your table is a probability distribution table. Let's deal now with your pre-assessment A. So let's have some recap. Evaluating summation. So the concept of summation is important before moving forward with the computation of mean. So we are going to use this concept of summation in computing the mean of a discrete probability distribution. So for your pre-assessment A, given the values of the variables x and y, so we're asked to evaluate the following summation. For number 1, we're asked to find the value of the summation of x. So we're going to add these 4, 2, 5, and 1. So let's try to get total of these 4 numbers. So 4 plus 2, that will be 6, plus 5, that will be 11. Then 11 plus 1 is equal to 12. So therefore, the summation of x is equal to 12. For the summation of y, so there's a given y sub 1, y sub 2, y sub 3, and y sub 4. So we need to get the total of these 4 y values. So we just simply add these 2 plus 1 plus 0 and plus 2. So that will be equal to 5. For number 3, we're asked to find the value of summation of xy. So we just simply multiply this one, your x sub 1 to your y sub 1, your x sub 2 to your y sub 2, then your x sub 3 to your y sub 3, then for last, we need to get the product of this x sub 4 to your y sub 4. So that will be 8 plus, that will be 2, since 2 times 1, it's 2, plus 5 multiplied by 0, so that will be equal to 0, plus 1 multiplied by 2, that will be equal to 2. So therefore, the total for the summation of x multiplied by y is equal to 8 plus 2 plus 0 plus 12, or simply equal to 12. Now, for number 4, the summation of x plus y. So we're going to add this x sub 1 to your y sub 1, so that will be equal to 6, plus your x sub 2 plus your y sub 2, so that will be equal to 3, plus your 5 plus 0, that will be equal to 5, plus your last combination, that will be your x sub 4 plus your y sub 4, or simply equal to your 3. So the total for the summation of x plus y is equal to 6 plus 3, that will be equal to 9, plus 5, so 14, plus 3, that will be 17. So the final answer for this summation of x plus y is equal to 17. For the last summation, we're asked to find the value of the summation of 4 times the value of your xy. So we just simply multiply this 8 by 4, this 2 by 4, then 0 by 4, then 2 by 4. So 8 multiplied by 2, or simply I mean 8 multiplied by 4, that will be equal to 32, plus 2 multiplied by 4, that will be equal to 8, plus 0 multiplied by 4, it's 0, plus 2 multiplied by 4, that will be 8. So we're going to add this 32 plus 8 plus 0 plus 8. So that will be equal to 48. Therefore, the value of your summation of 4 times your x multiplied by y is equal to 48. So for pre-assessment B, let's have some recap or recall the process of finding the mean of a data set. Given the following are the scores of 40 students in a test, and we're asked to compute the mean score. In your first column, there's a given value of scores here. And in your second column, so there's a given number of students that will be mapped in each score in your first column. So 42 for 8, then 50 to 12, 53 to 9, 38 to 7, and 46 to 4. So let's try to recall the concept of computing the mean. So for example, if we're asked to find the mean of the grades of a student for his or her 9 subjects, no, we simply get the total or sum of his or her grades from his or her 9 subjects, then we divide it by the number of subjects involved. So the total of these 9 subjects divided by 9, that will be the value of your mean. Now, what will be the process in this situation? So in computing the mean of a dataset, this will be the process. So we're going to multiply these 42 to 8. So we're going to multiply this 42 to 8. So that will be equal to 336. Next, we're going to multiply your 50 to 12. So that will be equal to 600. For your next value, we're going to multiply this 53 to 9. So that will be equal to 477. Then for your next value, that will be 38 multiplied by 7, or simply equal to your 206. For your last value, the product between your 46 and 4, so that will be equal to 184. So in this case, no, so these resulting values between the product of your first column to your second column, or what I mean is that the product between the values under your first column and the values under your second column, this will be your resulting values. So we're going to add these resulting values, so that will be equal to 1,863. So how can we compute for the value of mean? So you need to check, or you need to assess, no, how many students are involved. So there are 40 students involved. So we need to divide this 1,863 by 40. So may I say your mean is equal now to 46.58. So if we're asked to find the value of the mean of the given values, no, our value now of our mean is equal to 46.58. For our lesson introduction, mathematicians usually consider the outcomes of a coin toss as a random event. That is, each probability of getting a head is 12 and the probability of getting a tail is 12. So if there is an involvement of a coin, and once we toss a coin, no, there is a 50% probability that we can get if a head and a tail. However, it is not possible to predict with 100 certainty which outcome will occur, because we need to take note the word random event. So it happened by chance or it will happen by chance. So there is no such thing that we can say that we're 100% or there is a 100% possibility that something will happen or something will occur. So it should be less than 100%. For our discussion points, the mean of a discrete random variable x is the weighted average of the possible values that the random variable can take. So if you're asked to find the value of the weighted average, the point average, or the mean of a discrete random variable, these are same concept. No? So if you're asked to get the value of the mean of a discrete random variable, you are simply asked to find also the value of the weighted average or the point average. So whatever the value that you can get in computing the mean of a discrete random variable, that will be the value of your weighted average and your point average. So for our discussion points, our illustrative example, considering rolling a die, what is the average number of spots that would appear? As part of the continuation of your discussion points, let's deal with your step number 1. So we need to construct the probability distribution for the random variable x, representing the number of spots that would appear. So we're using your variable x to represent the number of spots that would appear. Here, in your first column, these are the possible values of your random variable x. These are values that reflect as a value of your random variable x that will represent the number of spots that would appear in each possible outcomes that we are dealing with. In each possible values of random variable, there is a corresponding probability. So your numerator here is the number or how many times this random variable or the value of this random variable x, no, that represent the number of spots that would appear, how many times this one represent as a value of the random variable x. So that will be your numerator here. Now, what will be your 6? This will be the total possible outcomes. So if we count the numbers involved in your first column, so that will be from 1 to 6, meaning say the total possible outcomes is equal to 6. So therefore, the probability that we can map to your 1, to your 2, to your 3, to your 4, to your 5, and to your 6 is equal to 1 over 6. Because in a single die, your one spot uh, will be mapped to your one face of your die. So in every faces that you can see, in your die, there is a corresponding number of spots. So one spot for one face, two spots for another face of a die, up to 6 spots for the last face of a die. So for step number 2, so we need to multiply the value of the random variable x by the corresponding probability. Here, in your first column, these are the values of your random variable x. So in your second column, this will be the values of your probabilities that will be mapped in each random variable or values of random variable in your first column. So in your third column, this will be the product of your first column and your second column. Now, if we try to multiply this 1/1/6, so that will be equal to 1/6. So your 2 multiplied by 1/6, so that will be 2/6. Same thing with 3. 3 multiplied by 1/6, so that will be equal to 3/6. Your 4 multiplied by 1/6, so that will be equal to 4/6. Then 5 multiplied by 1/6, so that will be equal to 5/6. Then 1/6 multiplied by 6, that will be equal to 6/6. Now, so in your step number 2, so whatever your values under your first column will be multiplied to their corresponding values of probability in your second column. So whatever the product between your first and second column, so that will be the values that will be mapped in your third column. Now, if we're asked to find the value of the mean of this illustrative example, we just simply get the total or sum of these values, under your third column. So whatever the values that we can get from the total of these products, from your first and second column, so that will be the value of your mean. So if you try to assess these fractions, so these 6 fractions, so they are similar fractions having the same denominators. So we just simply copy your denominator and we add all your numerators. So that will be 1 plus 2, 3 plus 3, that will be 6 plus 4, 10 plus 5, 15 plus 6. So that will be equal to 21. So your 21/6 is the value of your mean. So for step number 3, add the results obtained in step number 2. So we just simply get the total or sum of all the values under your third column. So that will be equal to 21/6. Or if we convert this fraction to decimal, so that will be equal to 3.5. So the value of this mean for this illustrative problem is equal to 3.5. The mean tells us the average number of spots that would appear in a roll of a die. So the average number of spots that would appear is 3.5. Although the die will never show a number which is 3.5 because we can only see a number, a whole number from your die. That will be your 1, 2, 3, 4, 5, and 6. So there is no such thing as 3.5 spots in a die. So this implies that rolling the die many times, the theoretical mean would be 3.5. So we consider this one or this 3.5 as theoretical mean because in reality, there is no such thing as 3.5 spots in a die. That's why your 3.5 is considered as a theoretical. So for the last part of the discussion points, here is the formula for the mean of the probability distribution. The mean of a random variable with a discrete probability distribution. So your x sub 1, your x sub 2, x sub 3, and x sub 10 are values of the random variable x. Then your p of x sub 1, your p of x sub 2, your p of x sub 3, and your p of x sub n are the corresponding probabilities of these values of the random variable x. So if we're asked to find the value of your mean, so we just simply multiply your x sub 1 to your p of x sub 1, then your x sub 2, or to your probability that will be mapped to your x sub 2, then x sub 3 multiplied by the probability that will be mapped to this x sub 3 up to x sub n, and to each corresponding probability. Now, so we just simply get the total of these products of these values of random variable to their corresponding probabilities. So whatever the product, no, or I mean whatever the total or sum of these products, no, between your random variable x and to their corresponding probability, so that will be the value of the mean of the probability distribution. To go deeper for our lesson with this video, so let's go with our example number 1. So for the title, grocery items. So the probabilities that a customer will buy 1, 2, 3, 4, or 5 items in a grocery store are 310, 110, 110, 210, and 310 respectively. So when we say respectively, so if we're going to arrange these values to our table, so whatever the arrangement of these values of the random variable and their corresponding probability in the problem, the same thing with their arrangement in the table. So if 1 will be mapped to 3 over 10, then your 2 will be mapped to the second probability, then your 3 will be mapped to the third probability, then your 4 will be mapped to the fourth probability, and your 5 will be mapped to the last probability. What is the average number of items that a customer will buy? So with these values, no, of your random variable and their corresponding probabilities, we're asked to find the value of the average number of items that a customer will buy. So for solution to example number 1, let's deal now with your step number 1. So let's construct the probability distribution for the random variable x representing the number of items that the customer will buy. In your first column, these are values that will represent the number of items that the customer will buy. And in your second column, this will be the probabilities that will be mapped in each values of variable x in your first column. So for our step number 2, for our solution to example number 1, so we need to multiply the value of the random variable x by the corresponding probability. So again, we are just simply using the first two columns. Your first column here, that will be 1 to 5. Then their corresponding probabilities here in your second column. So in your third column, same process with your illustrative example. So we just simply multiply your first column or the values under your first column to their corresponding probabilities in your second column. So whatever the product between your first column and your third column, or the values under your first column and your second column, will be equal to the values under your third column. So let's begin. So 1 multiplied by 3 over 10, so that will be equal to 3 over 10. Same thing with your 2. 2 multiplied by 1 over 10 will be equal to your 2 over 10. So 1 multiplied by 3, 1 over 10, I mean, that will be equal to 3 over 10. So your 4 multiplied by 2 over 10, so that will be equal to 8 over 10. Then last, your 5 multiplied by 3 over 10, so that will be equal to 5 over 10. After getting the product of all values under your first column to your to the values, no, or the product between the values under your first column and your second column, so that will be your third column, or values under your third column. So we're going to get the total or sum of these values under your third column, and that will be the value of your mean. So let's check first the 5 values under your third column. Since they have the same denominators here, so we just simply copy your denominators, and we need to add or get the total of those numerators involved. So 3 plus 2, so that will be 5, plus 3, so that will be 8, plus 8, so that will be 16. So 16 plus 15, so that will be equal to 31. Now, your 31 over 10 is the value of the mean for this example number 1 problem. So for step number 3, for the solution to example number 1, add the result obtained in step number 2. So we're just simply add or get the total or sum of those values under your third column, which is the products, no, of all the values under your first column and all the values under your second column. So therefore, the sum and total of these products, no, under your third column is equal to 31 over 10. So if we convert this 31 over 10 to decimals, so that will be equal to 3.1. So the mean of the probability distribution is 3.1. This implies that the average number of items that the customer will buy is 3.1. So again, your 3.1 here is a theoretical mean, because in reality, there is no such thing as 3.1 items. So it should be a whole number. So, but with our computation, our resulting value for the value of your mean is 3.1. So therefore, your 3.1 here is a theoretical mean. So for your activity number 1 for this video lesson, so your task is to deal with the given values of your random variable and their corresponding probability, and you're asked to find the value of the average number of patients that a surgeon operates on a day. So you need to follow your step number 1, your step number 2, and your step number 3 in getting the value of the average or the mean of the number of patients that a surgeon operates on a day. So for the summary, the mean of a discrete random variable x is the weighted average of the possible values that the random variable can take. So if you're asked to find the value of the mean of a discrete random variable, it is just simply you're asked also to find the value of the weighted average or your point average, because whatever the value of your point average, that will be equal to your weighted average and to the mean of a discrete random variable x. In finding the mean of the probability distribution, so your first step, you need to construct the probability distribution for the random variable x. So you're going to make, or you're going to construct a table in your under your table in your first column. So that will be the values of your random variable x. In your second column, those are probabilities that will be mapped in each values of random variable x in your first column. For your second step, so you need to multiply the values of random variable x by the corresponding probability. So we're going to multiply the values under your first column in your table to the values under your second column. Then for last step, we need to add the result obtained in step number 2. So in your table, there is a third column there. So whatever the product between the values under your first column and your second column, so that will be the values that we can put on your third column. So after getting the product or products of values of the value under your first column and your second column, then we need to get the total or sum of these values. So that will be the value of your mean. Again, in finding the mean, you just simply multiply the value of your random variable x to their corresponding probability. Then after getting the product between these random variable x values and values of probability that will be mapped in each random variable x, then whatever the products, you just simply get the total of these products from your first and second column. So the total or sum of these products will be equal to the mean of the probability distribution. So this will be the end of our video lesson. Thank you for watching and God bless everyone.